What up, what up, what up, what up, what up, Sci Fam? It's your boy Nickel, and today we're going to talk about the latest coronavirus. As we just learned, earlier about the fact that coronaviruses are a whole family, we're going to learn about the one that has recently just become all over the news, has taken over the news, has taken over our world, has taken over our lives as we adapt and try to prevent the spread of the 2019 coronavirus. Now, this is being recorded on March 19th, 2020, but the coronavirus was originally detected in 2019, and so that's why we're calling this the 2019 coronavirus. So title your page, 2019 coronavirus, and let's review and remember the name of the virus. The virus is that little thing that's almost like a cell kind of, but it's the virus that is what's being causing the disease and causing the problems in people's health. The name of that virus, remember, was the severe acute respiratory syndrome coronavirus. If I can fit it on there. And that abbreviated is SARS-CoV, and we call it 2 because there was one before that was similar but a little bit different, so we call this SARS-CoV-2. And that's that actual virus. So it's that thing that would, like, with all the spiky projections on it, that would be the actual virus. But it causes the disease in humans that we have called COVID-19. So if you've heard SARS-CoV-2 or COVID-19, hopefully this makes a little bit more sense now that the SARS-CoV-2 is the virus, COVID-19 is the disease. Now, COVID-19 just means coronavirus, or coronavirus disease, which was discovered in 2019. So you can see COVID-19, that's how it got its name. Okay, that's the disease. That's what is hurting people. But it's caused by this little virus once it gets into people's bodies. The disease then is what we're actually seeing in people, and that's the signs and the symptoms. So let's take a look at the signs and symptoms of COVID-19. All right, so somebody who is infected by the virus and then gets the COVID-19 disease is typically going to have some or all of these signs or symptoms. So one is a dry cough. It can also cause a fever. Usually not a very high fever, but a slight fever. People that develop COVID-19 disease end up, because it's a respiratory disease, they end up with a difficulty breathing, or we could just say that they have a shortness of breath. They might also have a sore throat and potentially a runny nose. So we can see that, it's called severe acute respiratory syndrome, and the signs and symptoms are typically revolving within the respiratory system. So now that we understand that COVID-19 is the disease, which is caused by the virus, SARS-CoV-2, we can start to unravel why there is so much reaction to COVID-19 or the coronavirus of 2019 right now. So let's look at this severity of COVID-19. And let's compare it to some other viruses and other diseases that have affected humans in the past. So if we were to look at a graph here, if we were to make a graph, let's label our x-axis with the transmission rate. So if we look at how severe a disease is, we want to know how easy is it to transmit it from one person to another. We also want to know how often is it going to kill people? So we call that lethality. So if we were to graph lethality and transmission rate of different diseases, we can see how bad, how severe they are in affecting humans. So the higher up we go on the lethality, the y-axis, it means that it's going to become more deadly. So for example, if we put Ebola on here, Ebola is way up here. Ebola, people that contract Ebola have a high likelihood of dying from that disease. Whereas somebody that contracts chickenpox, we can put down here on the x-axis almost, it is not very lethal, or it doesn't kill a lot of people at all. So it would go down here lower. Now, as you go left to right on the transmission rate, the x-axis, the further to the right it is, it means that it spreads faster and easier. So you could say that chickenpox spreads easier than Ebola does. But if we look at it on the up and down, the y-axis, it's not very lethal. Okay, if we were to put the common flu in here, the common flu is down here actually. The seasonal flu that comes around each year, it kills some people. It is lethal. And as we all know, it does get passed between friends. So there is some effect in terms of it spreading from one person to another. So it would go kind of down there in that left corner. Now, if we remember those other coronaviruses that we looked at, MERS, the Middle East Respiratory Syndrome, would go somewhere right in there. It was a lethal disease, but it wasn't as easy to spread as SARS was, and SARS was a little bit less deadly. So we could put SARS, and I'll put CoV-1 on there. Now, if we were to show where, I can't put CoV-1 there because that's actually the virus, and we're just looking at the diseases right now on this, so I'm going to erase that. So the SARS disease would be there, MERS there, and if we were to then plot COVID-19, the disease that is currently affecting our world, it would be somewhere in here. And it's kind of tough because right now, since it's all unfolding as I'm creating this video, right now scientists don't know where it would fall within this kind of like square that I just drew. So I'm going to draw this square. I'm just going to write COVID-19 within it. But you can see that it's definitely a lethal disease, and it's also one that is easy to spread. All right, well, let's look at the specifics of COVID-19 in terms of its lethality. And afterwards, we'll look at the transmission rate and compare the transmission rate of COVID-19 with a couple other diseases. So first, the lethality. Well, if we look at how many people are dying from COVID-19, it's anywhere from 0.6 to 4% of infected people are dying. Now, when you look at that number, you might not think that it's a very large number, but let's compare it to the seasonal flu. So if we compare it to the seasonal flu, it's anywhere from 4 to 20 times higher, or more people are dying from COVID-19. Anywhere from 4 to 20 times more people die from COVID-19 than the seasonal flu. So that can be a huge impact to our population. Now, it's a huge range because still we're trying to understand this disease since it's currently affecting our population. The numbers, there's still quite a wide range in the numbers. And it specifically is affecting populations that are greater than or over 70 years old. I'm just going to abbreviate that. And in populations greater than 70 years old, if we look at that mortality rate or how many people are dying, it's anywhere from 10 to 20%, which means that if 100 people over the age of 70 were affected, 10 to 20 of those people would actually die from that disease. So it is definitely a lethal disease. And so one thing that we want to be careful with is we don't want to spread the disease if it's that lethal. But if we look at this actual virus, let's look at what the transmission rate is. How easy is it for people to spread it? Well, a number that is used to describe transmission rate, and you might even see this in the news, it's R with a 0 in the subscript, like the lower area. Some people call this R naught or R0, R sub 0. And this is just a fancy way that scientists use that nomenclature to describe what the reproductive number is. And that so R naught stands for reproductive number. And that basically is just how many people, the reproductive number means how many people are typically infected by one sick person. So if one person gets sick, how many other people are going to become infected? Let's start with the flu, the R naught of the flu. So if one person has the flu, typically they're going to spread it to 1.2 to 1.3 other people. Now, this is like, they use some math to figure this out. So the 1 point, you can't infect like 0.2 of a person or 0.3 of a person. But when we average it all out, it goes, the flu, if someone has the flu, they're going to infect anywhere from 1.2 to 1.3 people. COVID-19 then, let's take a look. This is going to infect, if one person gets sick, there's a likelihood of them infecting 2.24 to 3.58 people. So you can see it's much more easy to transmit COVID-19 than it is the flu. But it's not necessarily the worst thing either. Measles, the R naught value of measles isn't just anywhere from 12 to 18. So if one person has the measles, they're going to infect somewhere between 12 and 18 other people. All right, so we're getting a little bit more information about COVID-19, and maybe you're understanding why they're asking us all to self-isolate and to quarantine ourselves if we get sick, because it's easy to transmit and it is killing a lot of people that get it. So let's think about this idea of transmitting this type of disease. Now, if you're in a place, then this disease, this virus can live on different types of surfaces or in the air. And so scientists did a study just recently, just in the last month, to try to understand it better. And so what they did is they tried to see how long could it survive, the survival rate on different surfaces. And so when we look at things like in aerosols, so like in the air, if someone were to like sneeze or cough in the air, the virus can stay in the air for up to 3 hours. Now, what that means is it's the electrostatic potential of the virus. So basically, if you think about like dust particles that are in the air, they kind of float in the air, but eventually they kind of fall down to the ground. Now, ones that are a lot bigger are going to fall much faster, and ones that are smaller might fall slower, and others might just kind of hang out in the air and not fall at all. Well, it takes about 3 hours for COVID-19 to be able to fall out of the air. So in an aerosol in the air, it takes about 3 hours for it to then be gone if one infected person were to spread the disease, the virus, throughout the air. Okay, well, if someone touched something that was a copper material, a copper metal, it lasted for about 4 hours on copper. Think about if someone went to the grocery store and picked up a box of cereal and they put it back, or picked up a box of Kleenex and put it back, or they maybe just slid their hand along the counter aisleway and there was a bunch of boxes of food there. Well, it's important to know, how long does it survive on cardboard? Any guesses? 24 hours. So for a whole day, it can live on cardboard surfaces for 24 hours. And lastly, if we look at plastics or stainless steel, which as I go around, and I pump my gas, I think about this idea of like plastic and stainless steel. How long, if someone were sick, if they were to pump gas before me, how long could it stay on there? Well, it could stay on there and still infect me for 2 to 3 days. So when we think about the transmission rate and the lethality, it's important to think about, well, it can live on some surfaces for a long time. It can stay in the air for a long time. And so this is part of the reason why we are being asked to self-isolate or practice social isolation and to quarantine, is because this is a pretty hardy virus. It can stick around for quite a while, and it can affect people long after the sick person is out of the room. So be careful out there. Wash your hands after you touch different surfaces to try to get this virus off your hands. If you were to get it on your hands, keep your hands away from your mouth, blah, blah, blah. You read the news, you've probably seen what to do. I'm just trying to teach you why they're telling us to do that. So hopefully you know a little bit more about the 2019 coronavirus. We're going to keep going though. We're going further into this, and I'll see you in the next video. Peace.